Hello friends, in this video I'll be talking about the basicity, the factors that can affect the basicity. Previously I have made more than 2 videos about factors that can affect basicity. Please watch those videos if you haven't. In this video I will be talking about the inductive effect, how inductive effect can affect the basicity. I have already made videos about acidity. If you haven't watched those videos, please watch. So the inductive effect is of two types, as you already know that I have made video about inductive effect. If you haven't watched, please watch that video. So inductive effect could be negative and could be positive, like electron withdrawing groups which are more electronegative in nature are going to show electron withdrawing inductive effect or negative inductive effect, and the electropositive elements or electron donating groups are going to show the positive inductive effect. So the trend would be the electron withdrawing groups inductively they will decrease the basicity. Those groups which can withdraw electrons density via negative inductive effect are going to decrease the basicity compared to those groups which are going to donate the electron density via inductive effect. They are going to increase the basicity. So have a look at this example. So the concept is electron withdrawing groups decrease amine basicity. So if you are giving these two examples, which is going to be the more basic hydrogen, or which is going to be a most basic nitrogen among these two, the colored blue one is morpholine, another one is piperidine. Now if you look at closely to these two compounds, both contain 6 member rings, both contains NH groups. The only difference is the additional oxygen atom in morpholine, and there is no any heteroatom involved in piperidine except nitrogen. So the deciding factor will be the inductive effect. That's how you can apply concepts to the basicity in order to predict which is going to be more basic in nature. Oxygen, as you know, is more electronegative element, and it acts as an electron withdrawing group inductively. So it withdraws electron density, hence renders this morpholine as less basic. Whereas in piperidine there is no additional group except NH, hence this NH is more basic. So this is how inductive effect is implied in understanding the nature of basicity of compounds. If you look at the pKa value of morpholine is 8.36 and the pKa value of piperidine is 10.9, and pKa is directly relationship with basicity. Higher the pKa value, higher will be the basicity. Let's have a look at another example of pyridine now. One pyridine which does not contain any substituent, and another pyridine which contains chlorine at position 2. So that's a 2-chloropyridine and pyridine. Among these two, which is going to be more basic? So the concept that going to be applied is inductive effect, as chlorine is more electronegative in nature, hence it is going to withdraw electron density from the pyridine ring, hence it will render this 2-chloropyridine as less basic compared to pyridine ring. So pyridine is more basic, having pKa value of 5.2, and 2-chloropyridine is less basic, having pKa of 0.49. This is how inductive effect predicts the nature of basicity. Let's have a look at the more example about inductive effect that can affect the basicity of nitrogen atoms. Have a look at this example where we have an aniline, but it contains 4 different groups on 4 different compounds. So if you are asked which is going to be more basic among these 4, fluoro, 1, a chloro, bromo, or iodo, so you decide based on your knowledge about electronegativity, as iodine is least electronegative among these 4 group members, then this is going to be more basic, and fluorine is most electronegative, hence it withdraws electron density from the aniline ring via negative inductive effect, hence the fluoro containing aniline is 4-fluoroaniline is least basic, and 3-chloroaniline is more basic than fluoro 1, and bromo is more basic than chloro 1, and iodine is more basic than bromo 1, hence iodine is the most iodine containing aniline is most basic, and fluorine containing aniline is least basic. Have a look at another example which is more basic among these two. So we have a methoxy group and we have a nitro group, and aniline is common in these two examples. So methoxy group acts as an electron donating group via resonance, and nitro group acting as an electron withdrawing group via resonance. So as you know that electron donating groups increase the basicity and electron withdrawing groups increase the basicity. So that's the resonance concept So if you have electron withdrawing group attached with aniline, they are going to decrease the basicity, and electron withdrawing groups, which are the groups which are going to donate electron density via resonance, they are going to increase the basicity. So methoxy containing aniline is more basic than the nitro containing aniline. I hope you like this concept about basicity. If you haven't watched my videos about this channel, please watch so and subscribe this channel. See you, bye.